So let me know once you're able to see the screen.
I can see your screen now.
Okay, that's great. All right, let's get started. So today we are going to do ratios, percents, fractions, and if time permits, we are also going to go through time, speed, distance, and work time. Let's see how much can we cover today. So some of these things are pretty basic, but nevertheless, these could be tested on the GRE. Some advanced concepts related to these, but let's start with some basics. So fractions, we know what they are. So one of the questions which could be asked is to compare two fractions and assess which one is larger. Yeah, so here we have two fractions. So the best way to solve such kind of questions is to cross multiply. So when we have 5 by 6 and 7 by 9, we need to cross multiply. So 5 into 9 is 45 and 6 into 7 is 42. So clearly the LHS is greater, which means 5 by 6 is greater than 7 by 9. So basically it's like taking the LCM, correct? Of the denominators, 6 and 9, and multiplying both of these by the LCM. So that's the logic behind cross multiplying. Yes, straightforward, right? Okay,
Yeah.
next. All right. So this is a fill in the blank question. So if x is between -1 and 1, but x is not 0, which has the greater value? Mod of x to the power 4 or x to the power 5? Now, when we look at this, clearly this means it's a fraction. So x between 1 and -1, but x not equal to 0 means it's a fraction. And if any number is a fraction, its power will even further reduce that fraction. For instance, half versus half cube. Can I say half is higher and half cube is lower? So whenever we have a fraction and we are raising it, the resulting number or the resulting fraction is going to be even lower. Yeah, so this is commonly tested on the GRE. Please make a note of this before we continue. Next. All right. In some questions regarding related to fractions, we need to be careful with zeros, 10 to the power decimals or 10 to the power some of these numbers, right? So for instance, in this fraction, In the numerator, we have 0.003, which can be simplified as 3 into 10 to the power minus 3. We can retain 22.4 as is, but then it has a decimal. So again, I will convert that into 24 into 10 raised to the power minus 1. This is the second number in the numerator, and the third as is 10 to the power 4. And then I divide this by 0.09 is 9 to the power minus 2 into 4 as is into 10 to the power minus 2 as is. So
Yeah.
the first point here is that express decimals in terms of powers so that it's easy. Also remove decimals wherever possible. Even if it's 2.4, just remove it so that it's easier to work around with the number. And then the next step will be to collect all powers. And the numbers. So clearly this will be 3 into 24 divided by 9 into 4, and then all the powers. So 10 to the power minus 3, minus 1, and 4, can I say will get cancelled out here. And in the denominator, we have these two. So these become 10 to the power minus 4. And we can simplify, this is 3, this is 6, so 6 by 3 is 2. So ultimately we have 2 into 10 to the power minus 4. When I shift this in the numerator, it becomes 2 into 10 to the power 4, which is 20,000, 4 zeros behind 2. So always 10 raised to n will tell us how many zeros behind the digit. If I were to write 2 into 10 to the power minus 4, it means there are 4 decimals. So this can be written as 0.0002. So these are some of the basics involving decimals, fractions. You might receive an easier question on decimals or fractions, and hence I'm just revising these concepts. Cool. Should I go ahead? Okay.
Yeah.
Sorry, we were at this question, and the question was which is greater? What is greater, x to the power 4 or x to the power 5? Now, as soon as you increase the power, that fraction becomes even lower. So clearly, when I compare x to the power 4 and x to the power 5, and if x is a fraction, then either, and it's a mod, which means negative number becomes positive. So when I compare these two, clearly this has a lower power, and the right side x raised to 5 has a higher power. So whenever you have a higher power, that number becomes lower, involving a fraction, which means x raised to 4 will be greater than x raised to 5, mod of these two. If mod is not given, then we need to be careful, because then if it's positive, okay, so what if there was no mod here? Another variation of this is they're asking which is higher. Now, there are two possibilities or scenarios for x. It can be a positive fraction or it can be a negative fraction. So if x is a positive fraction, then x to the power 4 will be greater than x to the power 5. Example is half raised to 4 is greater than half raised to 5. But if x is negative, then the story flips. then x to the power 4 is less than x to the power 5, because minus half raised to 4 is less or greater. So now it depends on the powers, okay? So if you have even, please note, if you have even versus odd, you need to be careful, because even power of a negative number will make it positive, right? So if I were to compare odds, then yes, this relationship holds true. For instance, half raised to 3 and minus half raised to 3 and minus half raised to 5. Can I say minus 1 by 8 is lower as compared to minus half raised to 5? So whenever you have higher odd powers, those will move the number towards 0. So they will become less negative and hence they will be greater. But if it's even versus odd, then the even power will be higher. So your x raised to 4 will be greater than x raised to 5 if x is a negative fraction. So that is even versus odd versus odd. And when both are positive. Now, why am I doing this? Because some complicated problems could involve you having to solve for various scenarios. Remember, yesterday we were doing quant comparisons in which D is also a possibility, which means it cannot be answered. Usually the answer is D when different scenarios are, giving us different relationships. Yeah, so hence to answer quant comparison kind of questions, it's important to list out various kinds of scenarios which could possibly give us different answers. So which is why it's important to analyze these things. So these are some of the basics on fractions, their powers. Also be careful if it's a negative fraction, whether it's raised to even or raised to odd power. Very, very important. Yeah. All right. Of course, we'll be practicing later many of these variants. Next, percentages. So some basics on percentages. 17 is what percent of 85? So such kind of a setup will basically mean 17 divided by 85 equals to what? 17 is what percentage of? So whenever you have the word of, that means the denominator will follow, which means we are talking about the next number being the base. So 17 is what percent of 85? So this can be reduced to 1 by 5. And can I say that is 0.2, which in percentage terms is 20%. So whenever you want to move from a decimal to a percentage, you need to just multiply by 100 and express that as a percentage. Which also means that if I give you 2% in decimals, it means you need to divide by 100, which means 2% becomes 0.02. 0.2% becomes 0.002 and 0.02% becomes 0.0002. Which also means when we're converting from a percentage to a number, which is basically a decimal, you need to multiply by 10 to the power minus 2, which is nothing but divide by 100. Correct?
Yeah.
So this is how it looks. So conversion from decimal to percentage and percentage to decimal, just the opposite, flipping. So we need to be careful with the language sometimes. The language could be confusing. Yeah, so generally what comes after off is the base. Next. Now this question is, all 1,000 registered voters in Smithtown are Democrats, Republicans, or Independents. So I will shorthand them as DRI. If 75% of the registered voters are Democrats and 5% are Independents, how many are Republicans? So I will write DRI. We know the percentage is 75 for Democrats, 5 for Independents. Clearly, the sum of these percentages should always be 100 for the entire set, which means I becomes 20%. Sorry, we're given I as 5 and we are asked Republicans. What is R? So R is clearly 100 minus 75 minus 5, which is 20. So 20% are Republicans and total voters are all are 1,000. And total are 1,000. So how many are Republicans? Can I say 20? So Republicans are 20 percentage of 1,000. So 1 by 5 into 1,000, 200. Or you can also do 20% is 0.2 into 1,000. That is 200. So 750 Democrats, 50 Independents, and 200 Republicans. But we focus on what is asked. Always the question stem is important. Sometimes there could be a negative on the question stem, and that's a common mistake on the GRE. So always look out for not. Then you have to answer it in the opposite fashion. Yeah. The complement of the answer is what should be marked in that case. All right. So easy one. So how to convert fraction into a percentage? So what is a percent equivalent of 5 by 8? So whenever we ask percent equivalent, always multiply by 100%. Yeah, so this is nothing but 5 by 8 into 100%. And that is 500 by 8. We can also simplify 4 by 50 and 2 by 25. So 125 by 2 is 62.5%. Yes, we can also remember these fractions. Some of these fractions can be remembered. For instance, 1 by 8 is nothing but 0.125. Yeah, so I can give you a list of these fractions. There are some 10 to 15 fractions to be remembered so that calculations become faster. So if 1 by 8 is 0.125, 5 by 8 becomes 5 into 0.125, which is 62.5%. So we can solve using some standard fractions, like 1 by 8 is 0.125. So some of these fractions are easy to remember. So half is 0.5, 1 by 4 is 0.25. These are easy. 1 by 3 is 0.33. Related item is 2 by 3. It's 0.67. 1 by 4 we've done. 1 by 5 is 0.2. 1 by 8 is 0.125. So 1 by 6, if I ask you 1 by 6, can I say that is half into 1 by 3? So 0.5 into 0.33, which is 0.16. Yeah. So these are some ways of converting a fraction into a percent equivalent. All right, let's move on. So percentages are also used to find the relationship between the parts and their wholes. So that is a percentage. For instance, an example is Ben spends $30 of his annual gardening budget on seed. If his total annual gardening budget is 150, what percentage of the budget is spent on seed? So total gardening budget is 150 and what is spent on seeds is 30. So percentage spent on seeds is part by whole, which is 30 by 150, which is 1 by 5, which is 20%. Yeah. Next. All good?
Yeah.
Okay. Percentage increase, decrease are regularly asked on GRE. And it's a very simple concept. You need to first identify the original or the base value that goes in the denominator. And over the original or the base, you need to find whether there was an increase or decrease. So if it's an increase divided by base, you get percentage increase, and vice versa for decrease, it's percentage decrease is decrease divided by original. Let's practice this. So 2 years ago, 450 seniors graduated from this high school. Last year, 600 seniors graduated. So 2 years back, it was 450. And now this number last year is 600. By what percentage did the number of graduating seniors increase? So to find the percentage increase, we have to find the difference, which means the rise, which can I say is 150, and divide that by the base. This is the base. The starting value is the base. So divide by 450. So answer is 1 by 3 or 33.33%.
Could you go back to the last slide, please?
Yes.
Okay.
Yeah. Can we move on?
Mhm.
Okay.
Yeah.
So here the base is the original value, which is the starting point 450 seniors 2 years back. And last year that number increased to 600. So the increment is 150. The base is 450. And that's how we set up the percentage increase.
Okay.
Okay. If the price, another question, if a price of a $120 dress increased by 25%, what is the new selling price? So original is 120 and the increase is 25%. So whenever we have been given an increase, all that we have to do is we have to add the base, which is 1, to this percentage, which means this becomes 1.25 times. So this becomes like a factor. So any increase or decrease problem needs to be set up like a factor. So the original price needs to be multiplied by a factor, which is either an increment or a decrement, and then you get the new value. So here it increased by 25%, which means it increased by 1.25 times. Why did I write this? Is because, for instance, if I have this 120, right? So the price increased by 120. So original price is 120 plus the increase will be 120 into 25%. So when I take the common 120, it becomes this, which is nothing but 120 into 1.25. So always it's the factor, right? So whenever we are given percentage increases or decreases, always convert them into factors. Had it been decrease by 25%, the factor would have been 1 minus 25%, which is 1 minus 0.25, which is 0.75.
Yeah.
Correct?
Yeah.
Okay. A commonly asked setup could be a multi-step percent problem. And this is a classic example. The price of an antique is reduced by 20%. So the original price is P0, which is given as $200. So this price first reduced by 20%, and then this price was further reduced by 10%. Maybe there was an initial sale period, and the leftover stock was probably, given a further discount on. So two successive discounts. So the question is, what is the final price? There are two ways of solving this kind of a setup. So the first method is that we convert into fractions, into factors. So minus 20% means 0.8 and minus 10% means 0.9 are the factors, which essentially means 200 into 0.8 into 0.9 will be the final price. Whatever that number is. Yeah. Method 2 involves the formula which looks like this. if in the first period the increment is A, and in the second period the increment or decrement is B, the formula for the effective increase or decrease is this formula. So this is the increase or decrease in part 1. This is for part 2. And this is the compounding. This gives us the effective increase or decrease. In our problem, how do we use this? So first it reduced by 20%. Next it reduced by 10%. So a formula is A plus B, which is A plus B. And then it is plus AB by 100, which is plus 20 into 10 minus minus divided by 100. A minus minus will be plus. So this will become minus 30 plus 2, which means the effective rate becomes minus 28%. Which also means that the original price after 2 discounts fell by 28%. So the final answer will be 200 into 0.72. That's the final answer. I generally prefer the first method because what if you have 3 successive increases or decreases? Then this formula won't apply. Then it will become a very complicated looking formula. So method 1 is preferred, which is using factors. Yes. So
Yeah.
successive changes can be solved using simple factors. Let's solve this one. Price of a share of a company A stock fell by 20% 2 weeks ago and by another 25% last week. So it first fell by 20 and then it fell by another 25%. Can I say original price is P0 and the final price is PT, final price. So first it fell by 20%, then it fell by 25%. Express in terms of factors. So this becomes 0.8, this becomes 0.75. 1 minus 20% is 0.8. 1 minus 25% is 0.75. Now so can I say that P0 into 0.8 into 0.75 equals to PT? Look at what the question is. Question is giving us nothing about the original price. The question reads as, by what percent of the current price does the share price need to rise in order to return to its original price? So can I say price from P0 has gone down to PT, correct? Now what the question is, by how much should it rise from PT to get back to P0? This is the question. So obviously the construction is opposite, right? Because here we are talking about falling, but now we are talking about rising. Flip the question, which means we need to get back to the original price, which means we need to express P0 as PT. So it will be P0 equal to PT divided by 0.8 divided by 0.75. And can you simplify this? Let me know what is the fraction you're getting here or the factor. 1 divided by 0.8 into 0.75.
1.66 times PT.
Okay. So what's the numerator? So PT into what?
1.67.
So 1.67, right?
Yeah.
Which means PT needs to increase by 67% to get back to the original. Then you will get back P0. So the stock fell 20% and fell 25%. So the base is lower. So the stock will have to move even higher to cover for the lower base. So stock has to move up by 67%, which is this option. Yes.
Yeah.
So an application of the successive percent changes is this. So always convert percentages into factors. Establish a relationship between the original and the final price, and then try to solve the problem for whatever the problem is. Sometimes we might know P0, sometimes we might know PT, sometimes they would ask for a flipping of the relationship between P0 and PT, just like this question. Yeah. So it depends on what is asked. Next. Percentage word problems are commonly asked on the GRE, and a popular category of that are profit loss, discount, cost price, selling price, variety of problems. They could also ask interest related problems. So this is an example of that. If an investor invests $100 at 20% simple interest, so principal is 100, interest is 20%. How much does she have at the end of 3 years? So simple interest formula is P. So this I can write it as rate R. So the formula is PRN. Principal, the interest, and the number of years. The rate is always in percentage terms. So P into R will give me the interest for 1 year. And if I multiply by N, it will give me interest for 3 years. So P into R is giving me interest annually, and PRN is giving me interest for N years. Yeah. So in this problem, you need to just multiply 100 with 20% with 3, and that will yield us the simple interest. So in this question, it's 100 into 20% into 3.
Yeah.
Yes. Okay. Ratios. Okay. So ratio related problems are of various kinds. Okay, so we will solve some of the kinds, and when we practice more, we'll come across other different kinds. So it's a vast area, ratios, but one of the varieties could be this, which means either the numerator or the denominator or both are changing. For instance, here it said, it starts by saying x by y is 1:4. So the ratio of x to y, which means x is to y, is 1:4. So that's the first equation. Now the second statement reads, if the value of x were increased by 1, so x is increased by 1 without changing the value of y, so the denominator remains the same, the ratio of x to y would become 1:3. So this ratio changes. So this is equation number 2. If z is equal to x plus 2y, they're asking what is z. So clearly to find z, we need both x and y. So this is, can I say, a set of simultaneous equations, the ones which we did yesterday. So how do we solve this?
Could you split x plus 1 over y into x over y plus 1 over y and solve for y?
Yes. Then combinations will apply, right?
Mm-hmm.
Then you can subtract 2 minus 1 or just substitute it here. So 2 minus 1 will fetch you 1 by y equals to 1 by 3 minus 1 by 4 by 1 by 12. Which means y is 12 and this can be substituted in 1. So x equal to y by 4. So x equal to 3. So we know y, we know x, and we can find z. So now z becomes x plus 2y, 3 plus 2 times 12. Yes?
Yeah.
Okay. So one common variety is one of the numerators or denominator variables change, and that gives us another equation, solve simultaneously and find whatever is asked for. All right. Ratio problems could also involve conversions of units. And how does this look like? Let's see this example. Jack drives a car that was manufactured in Europe. So the fuel economy read out on his dashboard is stated in L by kilometers. So in Europe, it's L by kilometers. If the value shown is 0.095, what is the fuel consumption rate stated in America? And the convention there is miles per gallon. And we have also the conversion rates given. So 5 miles is equal to 8 kilometers and 1 gallon equals to 3.8 liters. Now the way we solve this is, whatever is known, so we need to, can I say we need to convert this EU into US, which means EU is in L by kilometer, and we need US as M versus gallons, which means miles versus gallons. So clearly it means we need to work with L and km and convert these. So L will be converted into gallons, which is liters into gallons, and kilometers will be converted into miles. How do we do that? We make the use of these two equations. For instance, 1 gallon is 3.8 liters. So hence can I write 1 by 3.8 gallons is equal to 1 liter. Right? So convert everything into 1 liter and 1 kilometer, basically, because that's 0.095 isn't liters per kilometer. So convert L into gallons, kilometer into miles. So this, which means liter into gallons will be 1 by 3.8 multiplication. And kilometer into miles is using the above equation. 5 miles is equal to 8 kilometers, which means 1 kilometer equal to 5 by 8 miles. So 1 kilometer is 5 by 8 miles. So if we have to flip from 0.095 liters to kilometer, we need to multiply by 1 by 3.8. So liters will become gallons, and in the denominator is kilometer. So that has to be converted into miles, which is 5 by 8 miles. So we have in the numerator liter to gallons, and in the denominator kilometers to miles. So always write it in the form of numerator divided by denominator so that there is clarity. Numerator will be converted into gallons, denominator into miles, and multiply by the respective conversion factors. Yes, and when we simplify, we will get the conversion. Sounds good?
Yeah.
So these are problems related to conversions of units. Always express what is known into what is unknown. So 1 unit of known is how many units of unknown. So we knew liters, but 3.8 liters is 1 gallon. So we need to understand what is 1 liter. So that is 1 by 3.8 gallons. And similarly, we know 1 kilometer is equal to 5 by 8 miles. And that is what we substitute as these factors for conversions. And this is what we end up getting. Yes. Okay.
Yeah.
So that's how we set it up and solve this problem. Another variety is we have a series.
I have a question about the previous question.
Yes.
Um, so here you convert into gallon per miles. No, don't we have to switch it to miles per gallon?
Yeah. So if that is asked, if what is asked is miles per gallon, then you need to just take the reciprocal of that.
Mm.
Yeah.
Okay.
So depends on what is asked. Make sense?
Yeah.
Yes. So if gallons per miles is asked, then we retain this. If miles per
Mhm.
gallon, then just take reciprocal. Fantastic. Another variety in ratios is a number of different ratios could be given, and we could be asked the relationship between one variable versus the other. For instance, here A by B is 3 by 7. So always convert this is 2 into numerator divided by denominator. So A by B is 3 is to 7. C by D is 15 by 11. And B by C is 14 by 5. And they're asking us what is A is to D, which means A by D. So how do you think you can solve this?
Multiply A by B by B by C, and then you cancel out the B,
Mhm.
and you multiply that by C over D, and then you cancel out the C, and then you have A over D.
Absolutely. So method 1 is what you suggested, which means how to get A by D. That is mere multiplication of these three ratios. And what you end up getting is A by D. That's method 1. Method 2 is A is to B is 3 is to 7 and B is to C is 14 is to 5, right? So to make this equivalent, can I say your B is 14 and your B is 7 in the other ratio? Always take the LCM. LCM is 14, so multiply this ratio by 2. So A is to B becomes 6 is to 14. So then you have A is to B is to C as 6 is to 14 is to 5. And then you have C is to D given as 15 by 11. So C is to D is 15 by 11. So how do we get 15 on both? Can I say multiply each of these by 3? Correct? So now
Yeah.
eventually we end up getting A is to B is to C is to D as 18 is to 42 is to 15 is to 11, which means A by D is 18 by 11.
Yeah.
Sounds good?
Mhm.
Okay. So obviously this is simpler, right? But some problems could be better solved in this fashion. So I'm showing the concept of equalizing or normalizing the numbers using LCM method so that all the ratios can be compared. So how to compare the ratios? Just take the LCMs. Right? So the first LCM was between 7 and 14, which is this. And the next LCM was between this and this. Yeah. But it's always, so this is confusing. It's best to set it up as a series of different ratios and then keep combining the ratios. Yeah. But always method 1 is preferred. All right. A word problem related to ratios. So bag contains only green and blue marbles, and the ratio of green to blue marbles is given as 6:7. If there are 18 green marbles, how many total in the bag? So can I say 18 green? So by observation, the ratio is 6/7, but green is 18. So can I say the numerator is being multiplied by 3? So the denominator should also be multiplied by 3, which means you get B as 21, and you need total marbles, which is 39. So this is a quick way of solving. The other way of solving is G by B is 6/7, but you know G is 18. So 18 by B becomes 6/7. Then B is 7/6 into 18. Uh, yeah, which is 21. So whenever you can express the fraction as a factor, this method is faster. So we know 6 to 18 is 3 times. So the denominator will also be, I have to multiply it by 3. So blue is 21, total is 39. So this is a very quick method. That's only possible if you can, you know, the multiplying factor, which is an integer. Then it becomes easier to solve. Yes. Okay.
Yeah.
Another question. Red, blue, yellow gravels are to be mixed in the ratio. So red, blue, yellow to be mixed in the ratio 4:5:2. And totally 12 pounds of red gravel are available. How many pounds of colored gravel mixture can be made? So the ratios are given, and we know our red gravel is 12 pounds. So can I say from this ratio to the actual quantity, can I say it's being multiplied by 3? And can I say we need pounds, total pounds of the entire colored gravel mixture, which is R plus B plus Y. So when I look at these ratios, it's 4 plus 5 plus 2, which is 11. And can I say if I multiply 11 by 3, I should get the total. I could have also multiplied individually by 3 and gotten 15, 12, 15, and 6 and just added them up.
Yeah.
Yes. Okay. In a certain school, ratio of boys to girls is 5/13. If there are 72 more girls than boys, how many boys are there? So what is the equation here? Seventy-two more girls than boys. So can I say girls are more? So can I write girls equal to boys plus 72? Yes.
Yeah.
So the language sometimes can be confusing, but then just break it up properly. Clearly, they're talking about more girls. So will you add G plus 72 or B plus 72? Clearly, you're going to add B plus 72. So then you will get a higher number of girls, which is what this construct is. So always cross-verify in word problems. Always cross-verify your equation with the context. The clue is what is more. Identify the variable which is more. And that will fetch you the right answer. Yeah, so girls will be B plus 72. More girls than boys. And then we can solve this question. Also, here the ratio of girls is to boys is more, right? So here also, this is also giving us a clue that girls are more and boys are less. So sometimes you can confuse it like this, but this is not true because girls are more and boys are less. So always go back and check with respect to the other equation if possible, or with respect to identifying which is a higher entity or variable, larger variable. All right, so this was related to ratio. Another question. So quant comparison question. Ratio of bluegills to minnows to sunfish to bass in a pond is 5 is to 9 is to 4 is to 1. So BL is to M is to S is to BA. We've been given as 5, 9, 4, 1. These are the only kinds of fish in the pond, and total number of fish in the pond is between 100 and 200. So can I say the sum is between 100 and 200? So now they're asking which of these quantities is higher. Smallest number of minnows in the pond and the largest number of bluegills in the pond. So what do you think? How can we set this up?
Could you sum up the ratios
Yeah.
and then divide them by 100 and 200 to get the largest and smallest?
So are you going to divide
That
or
is,
you are going to put a factor to it? For instance, what you suggested initially was correct. So you have these ratios, right? These numbers. So the first step
yeah,
is to add these, which gives us some sort of a total because we need to work with totals.
yeah,
So total will be equal to and total will be equal to 5. So this is the ratio, right? So can I assume that BL is 5K, which means
yeah,
bluegills are 5K, minnows are 9K, sunfish are 4K, and bass is K.
yeah,
Ratios, if they are ratios, they can be expressed in terms of the variable, where K
mhm,
is a sort of a constant here or a multiplier. So which means the total becomes 5K plus 9K plus 4K plus K, and that is 19K, right?
yeah,
So the total, can I say, will be a factor of 19 for sure.
mhm,
So K values, can I say, will range from 1 all the way till 10. Can it have 1? It can't have 1 because the lowest number of fish in the pond are 100. So can I say 19 into 5 is how much? 95? 95 also cannot be the answer because these total fish have to be more than 100, which means K can be 6. So if K is 6, can I say this total becomes 19 into 6, which is 114. And
Yeah.
maximum K cannot go beyond 10, correct? Because if it becomes 11, then it will exceed 200 fish,
Yeah.
which means K, the range is between 6 to 10, range of K. Fantastic. If we have the range of K, that will help us find maximum, smallest and largest. See, whenever you're asked questions on smallest, largest, you need to somewhere express it in the form of a range in most of the problems. So if you have the range, then you can find what is the smallest and largest. For instance, smallest possible number of minnows in the pond, can I say will have the least value of K?
Mhm.
So smallest number of minnows is possible for K equal to 6. And minnows is equal to 9K, which means K is 6. So 9 into 6 is 54. Similarly, largest number of bluegills in the pond will be possible when K equal to highest value, which is 10, right? K least will give you least number, K highest will give you highest number. So K equal to 10, but the bluegills are how many? 5K. So 5 into 10 will give us 50. So clearly 54 is greater than 50. So answer is A. You can expect a difficulty level of this kind on the GRE, a hard difficulty level, in which you can be asked on smallest possible value in the question and largest possible value. So this can be set up in the form of a variable, which is K. If you know the range, you will know what highest value and lowest value of K are possible in the range. And once you find the least and the maximum value of K, then you can express the rest of the variables as a function of least value of K and highest value of K.
Yeah.
Yeah, so this is an important star mark here, important type. So when you want to score 85, 90, higher percentile in quant, we need to get such kind of questions correct. Yeah.
Yeah.
We have 10 more minutes, right? You have 10 minutes?
Yeah.
Okay. Next one. Okay. Another quant comparison on ratios. So 40% of 0.75 is A and B are these quantities. Sorry, there's something not right here. So this is 0.4. Okay. So find the difference. I mean, find what is A and what is B. So can I say A is 40% of 0.75? So it's a direct multiplication. Of means multiply. So 0.4 into 0.75. So we should start getting used to the PC calculator. So you'll be given allowed a simple calculator.
I have a question.
Yes.
In the exam, do they give us a calculator or do we take our own calculator?
No, it's the calculator on the PC which can be used.
In the exam, we use the PC.
Yeah, the
In
PC
the person exam.
online exam will be on the PC, right?
And the in-person exam?
So usually these are online exams because you can take them at any point of time. At least in India, they are conducted by Prometric, which is all online. So in the online exam, you'll have to use the simple calculator which is on the PC. So you can always pop it up and just do whatever calculations are needed. Yes.
Yeah.
Okay. So which is higher in this case?
B.
Yeah, B is higher. So simple one. All right. Twelve is X percentage of 60. So what is 30% of X? So they'll try to confuse you with some language, but we need to stick to our basics. So 12 is means equal to X percentage of 60. Of means multiply, is means equal to. So 12 is X percentage, and percentage means, can I say divide by 100? So 12 is equal to X by 100 into 60. So we can find X is 1200 divided by 60, which is 20. And then you're asked on 30% of X. Of means multiply. So 30% of X is 30% of 20, which is 6. Always, whenever you have a percentage, just divide by 100.
Yeah.
Right?
Mhm.
Yeah. Next, if a manager of a local grocery store earns an hourly wage of $21, so manager earns 21, assistant manager earns 25% less than the manager. I can express this as a factor which is 0.75. 25% less is 0.75. So that's for the assistant manager. And the stocker earns 60% less than the assistant manager. So stocker is 0.6, 60% less. What is 60% less? Can I say the factor becomes 0.4? So be careful, don't multiply by 0.6. It is 60% not off, it is 60% less, which means it's 1 minus 60%, which means it's 0.4. Also, assistant manager earns 25% less. It doesn't mean 25% off. Don't multiply. It's 25% less. So the factor is 1 minus 25%, which is 0.75. So stalker is 60% less, so means 0.4 of AM, which means 0.4 into 0.75 into 21. So that's S. So we have now the splits between SAM and MAM and S. So how much more does the manager make per hour than the stalker? Which means what is M minus S? This is simple. So what's the answer?
12.6.
Okay. Are you getting 12.6?
I'm getting 12.3 in the calculator, but
Sure. Answer is 14.7. Just check once more.
yeah.
So be careful in the calculator. Okay.
No, I'm getting 20. I'm getting 14 point.
Are you getting 14.7?
Yes.
Okay. Okay. So need to first multiply these two minus 1 and then multiply by 21.
Yeah.
Yeah. Always that BODMAS rule. So always multiply, then subtract, and then bracket, and then multiply. Okay. All right. One more question. Joe has a collection of 280 sports cards. 30% are baseball, 25% are football, and the rest are basketball, which means 45% are basketball. How many basketball cards does Joe have? It's pretty straightforward. Basketball cards are 45%. So this into total, which is 280, will fetch the answer. So no need to even solve. The answer will be 126. It will be slightly less than 50% of 280, which is less than 140, slightly less. So answer is 126. So on the GRE, as far as possible, I mean, we need to be slightly smarter. And wherever it's not required, let's not use the calci. Let's not waste time calculating. Yep. A lot of percentage changes problems can also be in the form of graphs or data interpretation kind of questions. So let's solve this. So here is a graph of number of collisions uh, by year. Okay, and these are collisions between birds and planes near this airport, Sherman Airport. The question is, find the number of collisions between birds and planes increased by approximately what percentage between 1990 and 2010. So this is 1990 and 2010. Percentage increase. So you can expect at least one such kind of question on the real GRE. Graph given, they're asking for percentage increase, decrease. Now, can I say the base is 12? So always have the start 12, end as 50. So I'll write S12, end 50. And the increment is 38. And hence, the percentage increase will be 38 divided by the base. Again, no need to solve. The answer will be more than 3 point something. And the only answer is this. And it's a percentage, right? So if I want to convert this into a percentage, multiply by 100. Then I get percentage. So simple. So this is how I write it. So 12 is the starting. Ending point is 50. Increment is 38. So percentage increase will be 38 by 12 into 100. So that will be your percentage.
Yeah.
Got it? Again,
Mhm.
need not solve and waste 2-3 more seconds. Yeah. All right. So that's about it. Any questions?
No.
So these are all some of the basic varieties in fractions, ratios, percents. And of course, as we move on, we will get into the thick of things, and we'll do a deep dive of these concepts, look at more variations, more complex varieties. So today was more of an introduction into these areas. Some questions were slightly tough, like the question on maximum value, least value. I think that required some conceptual understanding. I think it was this, right? This one.
Yeah.
So generally, when you have a series of ratios and there's a word problem, try to convert those ratios into uh, factors of k or whatever variable you want to put there. You can also put x. So 5x is to 9x is to 4x is to x. Add because we are talking about totals. And then why are we adding? Because first of all, the constraint or the range is on the totals, which is why we need to add these. So which is why we've added all these, said it's 19x or whatever k. So the total is a multiple of 19 clearly. Then we found what could be the k value depending on whether it's between 100 and 200. And then we solved for the smallest value takes smallest k, largest value takes largest k. Yeah. So difficult problems could be set up in this fashion. So
Yeah.
always the trick to solving is what is given as a constraint or a range. So your total is given, the range is given. So hence we are totaling this up. All right. So I'm going to send some practice questions tomorrow from both the
Yeah.
chapters, linear equations as well as this chapter. Around
Yeah.
25-30 questions I'll send you. You can, devote some time tomorrow. Uh,
Hmm.
Wordless, I hope you are through with Wordless too, is it?
Today I was really sick, so I couldn't really go through it.
Oh, okay, no worries. No problem. You can probably work
Yeah.
through it tonight or maybe tomorrow.
Hmm.
And the next session, we will revise word list too.
Okay.
Yeah.
Yeah.
Anything else for me?
Yep.
Okay, all good?
Yep.
Fantastic. So I'll be sharing this and some
Mm-hmm.
practice problems tomorrow morning. Yeah.
Yeah.
All right. Thank you so much.
Thank you.
Yeah. Bye.
Bye.